So, the Li or the Langelier index, this is defined as pH of the water actually, then pHs is the pH of the water in equilibrium with solid calcium carbonate. Now, this shows how much unsaturated the water is in terms of calcium ions. Now, I hope you can understand, if Li is greater than 0, that means pH is of the water is more than the pH of the water when it is in equilibration with calcium carbonate. Calcium will ooze out from the structures, it will go into the outside environment and precipitate over there, and that is why you see the color of piles becoming white. However, if Li is negative, that means pHs is more than pH, calcium carbonate will not precipitate. So, how should I put this in practice? Give calcium supplement to the groundwater. How would you do that? I hope you are realizing the similarity between our profession and the medical professionals. Read more about the negatives of grouting. Gone are the days when people used to grout and put cement or calcium into the soils. Why? Because somewhere down the point it is going to create some imbalance. See, this is how the subject is generating. I hope you are realizing that how the subject has got its value. So, you cannot just do grouting somewhere. Why? Person like me will come and catch you. I will monitor in my periphery of my utility or my property, and then I can prove that this is because of this activity, and I can trace also calcium by using different type of calcium tracers, that this is coming from this place and sue you. Yes, this is the word. This is what the practice is. There is something known as Reisner index. So, Reisner index also can be utilized to study how the scales are getting formed on the buried systems. So, this is 2 times pHs minus pH. You need not to remember all these, the codes are available. So, you need not to write down, just try to understand the applications, and maybe whenever you are in practice of the subject you can use this. So, if RH is less than 5.5, heavy scales will form. I hope you understand what is scaling, carbonates getting deposited. Now, another issue which I think you should realize, if any of these sort of things happens and if the calcium content of the groundwater changes, what is the major impact? Who is going to challenge you tomorrow? Agriculturists, those who are into the irrigation, those who are using this water for irrigation purpose. So, if you are grouting something and chances are that the calcium ions concentration becomes more, what is going to change in irrigation water? What is that term known as? There is the index, you must have studied. For irrigation water, what are the parameters? Calcium oxide divided by something, 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 summation of something. That tells you what is the, yes. So, you have to be careful. Hope you are realizing you can't practice your profession in isolation. Why I am giving this example? Clear? And if second thing is happening where the calcium concentration is decreasing in water, then also there is a problem, and calcium concentration will decrease by due to precipitation. So, if I have controlled the pH of the groundwater too much, what will happen? The chances are the calcium present in the groundwater might precipitate and your water may become saline. Now, if imagine if you are drinking saline water every day, what is going to happen? Not saline water, sorry, demineralized water. So, I hope you can realize now this is what is going to be a big issue. So, similarly, you can have different types of parameters of Ri, and then there is a classification which informs you whether the soils are corrosive or not. Fine. Now, whatever we did, I am just going to present about the assessment of corrosion potential of soil. So, when we talk about the underground structures and their durability, there is a code IS 456, you must have studied also 2000 on the corrosion of concrete. What type of cement should be utilized? There was a time when some of the cement industries used to contact me for doing microzonation of the soils where most of the infrastructure is going to come up. You know why? Because they wanted to create a cement and they wanted to launch it in the market by saying that this cement only can be utilized to counter the aggressiveness of the soil. So, these type of things go on where the research and the industrial activities join hands. So, it will all depend upon the type of cement. I hope you understand what is the meaning of the type of the cement, minimum cement content, maximum water cement ratio, and what is the exposure condition to which the concrete is getting exposed, and what is the sulphate and chloride contents which are prevailing at the ground water. So, then accordingly I can choose the cement. Of course, you have to analyze the complete soils to choose a certain type of cement to make concrete, and hence you can nullify the effect of corrosion potential. So, sulphate resistant cements are quite prevalent, is it not, in the market. So, from this point onwards you should study what is the corrosion of the material. So, this is basically electrochemical process, and there is a formation of corrosion cell, and I will show you what is the concept of corrosion cell. So, certain conditions, now these conditions could be environmental conditions, or these could be the anthropogenic conditions also. Nowadays, because we are studying too much of microbiology in geotechnical engineering under the realm of bio-geo-interface, we are realizing that there are bacteria or bacterial activities which might produce acids. So, the soils which are quite conducive for good infrastructure development might become very acidic because of the microbial activity or bacterial activity. So, one has to be careful, and this is where the sensing techniques have become very useful. So, that means I should be aware of what is going on inside the ground. Now, these type of thoughts come to mind because when we deal with the professional world, when we come across the industries where the failures have occurred, and when we do postmortem analysis, we realize that everything is right as far as the construction of the systems was concerned. But then the question is why failure has occurred, and when you do back synthesis of the failure, which is known as backward analysis or back analysis of the failure process, forensic examination, then you realize that these type of activities which have been ignored are quite prevalent. Hope this gives you the idea about what is happening. There is interesting literature on the effects of soil characteristics on corrosion, and this is the ASTM committee G1 on corrosion of metals, which sometimes people refer to for doing the analysis. There is a very interesting article, how the buried fiber optic cables, they are getting influenced because of the corrosivity of the soils, and in today's world everything is data, agreed. So, if you want to supply data uninterrupted and the power uninterrupted, then you have to study this subject quite closely. So, this is the conceptual discussion on corrosion cell. Now, what it indicates is that if I take the soil mass which is not dry, alright. So, maybe during rains the soils will become wet, and once the soils become wet, the electrolyte gets developed over there. This could be because of the groundwater also. The moment soil becomes wet, there could be a situation where cathode anode might get developed. Do not think that cannot have been inserted into the soil mass. Because of the electrochemical reactions, the chances are that certain portion of the soil might act as anode and certain portion might act as a cathode. That could also be because of the bacterial activity. Concentration of bacteria at one place in the soil mass would connote to something different than the another place. And if you remember, I think I was talking about long back that nowadays people are studying the microbial flushing also. So, from one place the concentration of microbes getting flushed out and might get accumulated at some other place. So, by virtue of anything, if a situation of this sort occurs that there is a cathode formation, anode formation in the soil mass which is wet, and because of being wet the electrolyte is present in the soils, the corrosion of certain portion of the buried element. So, now I would say that this anode is a pipeline, let us say, or a foundation or a pile, clear. So, the moment this type of situation gets triggered because of environmental parameters, the chances are that certain portion of the anode might get eaten up, and that is what the corrosion is. So, this is a conceptual model which would depend upon so many parameters, and I hope now you realize that why we have included some of these parameters in the neo classification schemes for the soil when we are talking about what is available in the literature and how the classification scheme should be modified, keeping in view the environmental influences. That right now the classification scheme is including these parameters, but what should be the futuristic classification scheme, what is required. So, if you read this matrix of the material properties which are required, the first thing is electrical resistivity, because for formation of the corrosion cell, the electrical resistivity of the soil should be as less as possible. Thumb rule says when the soils are in dry state, their resistivity is high. When they become wet, the resistivity decreases. Why? Because you have pore solution in the system and the ionic conductivity become faster or easier. This might force you to keep your system saturated all the time, but where is the water available to keep the saturated, particularly the foundation system saturated all the time, is a question. pH plays an important role, moisture content, porosity, sulphate and chloride content, redox potential, response of microorganisms and temperature, the big matrix. And if you come across this code DIN 509293, they have talked about the corrosion potential of the soils, because most of the systems are being designed by keeping these things in view. What is easier, to control soils or to control the structures which are buried inside? That is one of the ways of designing the whole thing, but then in the process you are using more materials and the cost of the structure is going to be extremely more. Another way of intelligently doing the whole thing would be prove that the soils are passive or create a passive system of the soils in which you bury a low cost structure which is not going to get affected due to the corrosion potential of the soils. So, this becomes an interesting practical problem. I hope you are realizing this. Why not? Yes, isolation is a very good solution. We do base isolation against the earthquakes. Please remember, all these structures you are designing for several years, and our pretext was that all these systems are directly exposed to the environment. Look at the coastal areas. How would you protect your foundations against the seawater intrusion? Check it out on net, what type of disasters have occurred because of the corrosion of the material, and then you will realize that how many buildings have collapsed. Yes, it is not a small thing. Fine. All this comes under the forensic examination, which is the need of the hour. And then we have to talk about what are the conditions of the soils, whether these are having base forming elements or acid forming elements. So, mostly carbonate, bicarbonate, chlorides, nitrates, sulfates, these are all acid forming elements, water soluble. When you have sodium, potassium, calcium, magnesium, this series, this is basically raising the pH of the system. So, they are basic things. Both are problematic. These type of studies have forced us to consider geotechnics of contaminated soils. Very soon you will realize that the soils which are contaminated will also get affected as far as their shear strength, permeability, compressibility, compactability parameters are concerned. And there are a lot of studies which have been done. So, if you are interested, please go through the literature and you try to find out what happens to the soils in terms of their shear strength when they are contaminated. So, I hope you realize that these are the gray areas in the subject on which a lot of research is being conducted. We tried to coin 6 parameters depending upon the properties of soils, and using these 6 parameters we have shown that whether the soils are going to be corrosive or not. You are free to modify this matrix. 6 might become 60 in your case or 6 might become 16 in your case, it is all up to you. So, we have devised a rating system for soils, and the rating system is based on soil fraction, which is nothing but the texture of the soil, particle size distribution. Rating is based on electrical resistivity, then pH, then groundwater status. The motivation behind using the groundwater status was the conventional geomechanics, where you use the B/D factor to reduce the bearing capacity of saturated, unsaturated soils, if you remember, correct? Submergence, effect of submergence. So, you use that d by d factor to define the location of the water table, and then you say if this is less than certain value, then the bearing capacity has to be reduced by half or something like that. Rating based on the sulphide content and the rating based on the chloride content. So, these 6 parameters were used for defining the corrosivity of the soils. Do not write these numbers, just try to understand how your research ideas are, first of all coined and then practiced, and then they precipitate in the form of the knowledge. So, we have defined this term R1 depending upon the particle size distribution characteristics, and these weightages have been defined arbitrarily. So, if a situation is helping in reducing the corrosion, we give positive marks, but if it is aggravating, then we give negative marks. So, if clay and silt contents are very high, the weightage is minus extremely high, that means this situation is going to be detrimental. Organic matter, if it is more than 5%, water retention will be more, permeability will be less, strength will be less, compactivity will be less, and hence extremely high negative weightage. Then severely polluted situations, again very high weightage, clear. The second is R2, resistivity, electrical resistivity. So, if electrical resistivity is very high, then this type of a situation has been given more weightage as compared to a situation when resistivity is extremely less. Then we have this effect of electrolytes, that is the pH. If pH is more than 9, less than 4, we have rated them in a different manner. pH less than 4 is more acidic, and hence the chances of corrosion are going to be more, and hence -3. Rating based on the groundwater status, if there is no groundwater, I will be very happy, but if water table is fluctuating, then this is not a very good situation, and if groundwater is there, -1. Then similarly sulphide content and chloride contents. So, extremely high values of sulphide content is not good, extremely high chloride contents are also not good. In coastal areas, you will have very high concentration of chloride content, approximately 4,000, 10,000, 12,000 depending upon the area in which you are working. Then ultimately what we do is we sum up all these parameters and we define the recommendations. So, when you sum up from R1 to R6, this is what emerges out. If R is positive, very good situation. If R is extremely negative, highly corrosive system. So, this type of thoughts we had proposed long back, and I think industries are using it and they are quite happy with this type of a classification scheme. So, coming back to the point, the classification depends upon what I am doing, I am pursuing. I can create my own classification scheme, which when validated by using different case studies become universal. So, I am sure for some of you it will be a very difficult thing to digest, that how classification system can be evolved based on your requirements, but that is what R&D is. You must have got some idea about how to do creative thinking and how to profess your ideas in practice. Then we talk about redox potential also. This is what is known as ORP, oxidation reduction potential of the soils. How easily the soils might get oxidized, and they might oxidize or they might reduce depending upon different type of constituents, and how easily the corrosion cell may get formed in the soils is what is known as redox potential. Nowadays things have become simple because there are probes which are used to check the ORP potential of the soils, oxidation reduction potential of the soils, alright. So, this is becoming pretty simple situation. One of the good examples is how Fe3 will get reduced to iron, and this is a good example of how the reduction of the iron might take place, what you were talking about in the buried condition. So, some people use this scale which is known as standard H scale, and this defines the redox potential of the soils in the millivolts. Redox potential depends upon the aeration property which you were talking about, when the systems are buried all the time or are saturated or submerged in water, then the chances of corrosivity are less. So, when the redox potential is more than 400, it is a strong aeration case, non corrosive environment. However, when you have redox potential as negative, there is no aeration. This becomes a case when anaerobic activities become quite severe in the soils and the corrosivity become extremely severe. So, again these type of studies are being conducted by people and they are trying to quantify everything. Just to show you a case which you were interested in seeing what is happening, I think this was the failure which occurred last year in Calcutta. Several bridges were failing and they were collapsing, and it so turned out that rather than the structural failure, the most of the failures are caused because of the corrosion. So, this is an interesting case of where a geotechnical engineer has given a report related to how the corrosion of the foundations and the material concrete is more responsible as compared to the structural issues. So, this was a very interesting case which people are citing now. The more and more underground construction is going on in the country, the problems are becoming more and more. I hope this gives you some idea about where we are heading to. Fine.